Hello, this is Thomas Trask for CS6460. Today I will be talking about the MyGang2 automated MOOC grouping software. As we all know, there's a lot of great things that MOOCs bring to the education spectrum. They're often cheap and or free, they're generally immediately available and fit a lot of busy schedules. They offer a college level experience for those who wouldn't otherwise be able to obtain it. But that doesn't mean that MOOCs don't have any room for improvement. For a lot of students who aren't used to doing work online, often find it isolating. The free nature of online courses often brings in voyeur students who never engage with a course, but still take up course resources. Lack of a day-to-day schedule can leave many underprepared students on the back foot. To combat this, some MOOC courses have put their students in groups. This tends to help keep the students engaged, it combats social isolation, it enriches the student experience, and ends up resulting in better per-student outcomes. That's not to say that groups don't have their own issues. Grouping the disengaged students with more engaged students tends to have a worse outcome for the more engaged students. Many courses don't lend themselves well to group work, and often in groups of students spread out across different time zones, like in MOOCs, you run into scheduling issues where students can't meet together. To combat this, Luisa Sanz-Martinez and her groups developed the MyGang application, which creates demographically homogeneous groups of 5 or 6 students, where strictly based on how engaged they were in the student forums. Even with this basic approach, her group found a significant increase in student engagement and performance and satisfaction at the end of the course, compared to randomized student groups. The goal of my research is to extend her approach to include more homogeneous demographic information, such as when a student is active on the forum, diction characteristics of a student's post, and grouping by student peer interactions. In addition to these metrics, the student will also be able to stack rank how important those metrics are to them individually and choose suggested group members based on both their interactions within the Piazza forum and their peers' interactions. MyGang2 uses a 3-step process to create group member suggestions. First, it aggregates all of the Piazza forum data for a particular class. It then uses this data to generate per metric per student linear regression models and ranks the students' peers based on how similar these regression models are to each other. Here we see a typical Piazza forum post being grouped by post text, post date and time, student poster, and the nested post list based on post response from each individual student. These individual data points will generate linear regression trend lines for each student. Each trend line will be compared to a student's peers to determine similarity, with students who have similar trend lines ranking higher than those who do not. Similarly, for the dictation element, all dictation data point trend lines are merged into one aggregate trend line, and a similar comparison and stack rank is made. Peer interactions are ranked solely based on student-to-peer interactions and do not use linear regression. This data, combined with a short survey the student takes during group selection, allows MyGang2 to generate a series of group member suggestions based on all of the previous mentioned criteria. The user interface was designed to be as simple as possible and afford the student as much immediate data and available data as they would need to make an informed decision. Please see the following demo for the regular use of MyGang2. Thank you for your time, and I look forward to seeing how this research develops in the future.